Next set of concepts that we're going to talk about is just the conversion from radical form to exponent form. And that conversion is just allowing you to rewrite a radical as a rational exponent. And the way that that works is, if you take a radical, the nth root of a to the m power, you can rewrite this as an exponent, keeping the base the same, keeping the power the same. And we've talked about this already. What we're going to do is move the index into the denominator of our power. Okay? So this exponent, this power, is a rational power. It's a fraction. Okay? Where the numerator is the power of the base, the denominator is the index of the radical. Okay? So if you did simply the square root of 2, in rational exponent form, we take our base of 2, our unwritten power of 1, over our unwritten index of 2. So 2 to the 1/2 power would be the square root of 2. Those are equivalent expressions. Okay. So if you did something like this, where you had the cube root of 9, let's say, and I asked you to rewrite this as a rational power. Okay, this is that case where you need to recognize the perfect powers. So perfect squares, perfect cubes, and so on. Because what do you recognize about 9? 9 is, in exponential form, it's a perfect square, 3 squared. And so now, once you simplify that completely, you can now convert it into this rational power form. We reduce our base. We have now a power for the numerator of our fraction, and our index is the denominator of that. And so the cube root of 9 is equivalent to 3 to the power of 2/3. And so if you were evaluating this on your calculator, all you would need to do is take the base 9 to the power of 1 over 3. But if you were doing this by hand and simplifying it, you would need to simplify it all the way down to the smallest base you can possibly use. Okay. Does that kind of make sense as far as finding the bases like that? All right, I want you to look at sample problem 11 really quickly on page 17. Okay, and see if you can answer those 4 questions. Find the rational form, the rational exponent form, for each of those, please. Right, so if you take this first one, we have our base of t, our power of 3, our index of 4. So you get t to the 3/4 as your simplified, or your radical written as a rational exponent. Okay, what do you think we would do with b? You have the 5th root of x squared in the denominator. So what can we do to move it? Or first, if we convert it into a rational power in the denominator. We have our base of x, power of 2, index of 5. But do we need to stop here? You can continue to simplify this and write it without the fraction. And that is, if we move the base up to the top, what do we have to do to its power? Make it negative. So we get negative 2 over 5. Is the rational power. So this would express the exact same thing. Okay, what about C? What happens here, and this is again one of the ways that you can simplify or look to simplify, but if we just took this directly as x to the 6th divided by, what's the index? 2, well, what does 6 has? Okay, now, is this all we need to do for this problem? Okay, think about, yeah, Michael, the absolute value. Okay, when you look at this, is the original index an even number? Yes, so you know that this solution has to yield a positive value only. So when you look to that, can you take a negative number to the 6th power and the square root of that and get a positive? Yeah. So we need to test it. If x were negative in this form, would this answer, this simplified form, be guaranteed to be positive? No. So in order to guarantee that, we need absolute values around the x.
Why isn't b absolute value? Because that's x squared.
On this one, the square itself is going to take care of that power, or of the sign. Because if x were a negative number, which again, because the index is odd, you don't even need to worry about it. But if x is a negative, when you square it, it becomes positive, and that's shown in this form here, with the power of 2. Now, in this form, in A, could t be a negative number? Can t even be a negative? If you take a negative, cube it, it's going to be negative. Can you take the 4th root of a negative? No, but that restriction is still shown in the form here. It cannot be a negative, so you don't have to worry about any absolute values of any kind. Okay. Finally, this last example, we have our base of t, our power of 7, our index of 2. Okay. Same thing, just like number 1. T can't actually equal a negative number in that case, and it's still apparent in the form of the answer as well. How come? Because it's a even index. If you put a negative in to start with, a negative to the 7th power or any odd power is going to be a negative. And can you take the square root of a negative number in the real number system? No. So you can't even use that. It's a restriction on the domain that's built into the problem itself.